All right, we're going to look at factoring polynomials. Now, what I want you to see in this video is that through lessons 7.5 through 7.8, there have been a lot of different methods that have been kind of introduced by the book for how to solve polynomials or how to factor them, just depending on their format, right? And so the book will say, if it's in the format x squared plus bx plus c, then factor it this way. And if it's in the format ax squared plus bx plus c, then factor it this way. And if it's in the format ax squared plus bx minus c, factor it this way. And I just want to kind of avoid that confusion, right? And so I'm going to boil it down into two steps. The first step is to ask yourself, is there a greatest common factor? If there's a greatest common factor, factor that out first. Okay, that's always going to be your first step. Once you've done that, or if there's not a greatest common factor, then move on, use a diamond like we introduced the other day, and then factor by grouping. This will work with any polynomial. Okay, so you can always use this. Now, along the way, you may see some patterns that emerge, and if you start to recognize, you can use those kind of to help you move a little bit quicker through some of these problems. But I'm just going to show us this method here, and I want you to apply that across the board until you're familiar or comfortable with some of those other patterns. So we're just going to look at a pretty good chunk of problems here just to practice this. So let's look at our first one. We have s squared plus 11s plus 30. So again, step one, is there a greatest common factor? I can tell that there's not, so we're going to start with our diamond, right? So again, the top is going to be AC, so that means a, which is in this case 1, because that's our coefficient for s squared, times c, that's this constant here, that's in the top, and in the bottom is our term b, which is 11. So we need to find two numbers that multiply to 30 and that add to 11. Okay, and it's okay if it takes a little bit of time to find these. You can even list out all of the factors of 30 if you need to, right? You could list out and say, okay, factors of 30. I know I've got 1 and 30. I've got 2 and 15. I've got 5 and 6. Okay, and 10 and 3. Now, if you need to do that, that's fine. We will see ultimately that 5 and 6 are going to be these two numbers. So now we can just rewrite our polynomial as s squared plus 5s plus 6s plus 30. And then we factor by grouping, right? So we can turn this into s squared plus 5s plus 6s plus 30. Now for each of these, we factor out any common factors that we see. So this would be s times s plus 5. I apologize that my s's look like 5s. Plus, we can factor out a 6, which would give us s plus 5. So now our final factored form would be s plus 5 times s plus 6. Okay, so what I do want you to see here, when we have a polynomial where our a, right, that's this coefficient, is 1, you'll probably notice when we did our diamond, we had 5 and 6. So you can actually know when this is just 1, right? When this is s squared or x squared or b squared or y squared, okay? You're always going to end up, right, with your factored form, you're always going to have s and s, or x and x, right? That's going to give you that x squared, that s squared. And then you're going to have that 5 and 6, right? Those two numbers that multiply to AC and add to B. So you could look at something, right? If you want to see another example, if we had x squared minus 3x minus 4, right? Once again, our A term here is a 1. So we could use that to know, all right, when I do my diamond, whatever multiplies to -4 and adds to -3, those are going to be the two other numbers inside my parentheses, right? And I'm going to have an x and an x here because those will give me my x squared. and I know that this has to be -4 and +1. So this would be x minus 4, x plus 1. Okay, but again, it's okay to not just jump straight to this step. You can do all of your grouping and you'll still get the same thing. So if you wrote this out as x squared minus 4x plus x minus 4, you can then factor and get the same result. Right? You'll see we factor out an x, we get x times x minus 4 plus 1 times x minus 4. And that leaves us with x plus 1, x minus 4. Okay, so once again, we can always use this factoring by grouping from our diamond. Okay, let's go ahead and do this one. Z squared plus 7z minus 18. Once again, we ask ourselves, is there a greatest common factor? The answer is no, so we make our diamond. AC is -18, B is 7. So we need to find something that multiplies to -18 and adds to 7. Okay, well it's going to be, we need one negative factor, right? So I know this will be 9 and -2 because 9 plus -2 is 7 and 9 times -2 is -18. So now we can write this as z squared plus 9z. Okay, when we have a negative factor here, it's going to be a lot easier for you if you write it as plus -2z, okay, rather than writing minus 2z. So we've got plus -2z and then minus 18. Okay, now again we can factor by grouping. So I'll factor out the z. That leaves me with z plus 9. Plus I can factor out a -2. And that also leaves me with z plus 9. So I have z minus 2 times z plus 9. All right. Looking at the next one, we have 8v squared plus 8v minus 48. We need to ask ourselves, is there a greatest common factor? Hopefully we can see that there is a greatest common factor of 8. So the first step is to factor that out. Okay, I know that that would factor out the 8. So 8 times v squared would be 8v squared. 8 times v would be 8v. And 8 times -6 would be -48. So now I've factored out that 8, and I can go ahead and do the rest of my problem. So we'll go with our factoring by grouping using the diamond. So here I've got, again, my a is 1, and c is -6. So this will be -6, and v, right, so my b term is just a +1. So I need to find something that multiplies to -6 and adds to +1. So in this case, that'll be -2 and +3. So now I'm going to have, right, I'll keep that 8 on the outside, and then I'll have v squared minus 2v plus 3v minus 6. Okay, we'll go ahead and set this 8 aside for a second while we factor this by grouping. V squared minus 2v plus 3v minus 6. We can factor out that v. We get v minus 2. And we can factor out a 3. And we get v minus 2. So our final factored form, don't forget the 8 that we had factored out before. We have 8 times v minus 2 times v plus 3. So now we'll go ahead and look at this next one, and you'll see this time it says solve, and we have our polynomial 25 minus 4x squared equals 0. So because it is set to 0, we can actually factor this and then solve for x once we have done it. So again, our first step is to ask ourselves if there is a common factor, and we can see in this case that there is no common factor. So then we can go ahead and first of all rewrite this in standard form, right? So this would be negative 4x squared plus 25 equals 0. And then in this case, I can see, right, there is no b value, right? There's no coefficient for just a plain x. So in this case, b will be 0, and AC is negative 100. So we need something that will multiply to negative 100 and add to 0, right? So we can see that'll be negative 10 and positive 10. So we could then rewrite this as negative 4x squared plus 10x plus negative 10x plus 25. And that all equals 0. And then we can factor. So we'll group these. And in this case, right, I can factor out a negative 2x. That leaves me with 2x minus 5. And from here, I can factor out a negative 5, leaving me again with 2x minus 5. So then I have negative 2x minus 5 times positive 2x minus 5, and that equals 0. So now I know, right, I want to solve this, and I know it equals 0. This whole thing, negative 2x minus 5 times 2x minus 5 equals 0, then at least one of these terms would have to equal 0. So we can set both of them equal to 0 to solve for x. So we have negative 2x minus 5 equals 0, and we have positive 2x minus 5 equals 0. So you get x equals negative 5 over 2, and x equals 5 over 2. And those would be my solution to this polynomial. All right, with this next one that we want to solve, it's not currently set to 0, and it's also not in standard form. So the first thing we could do would be to add 4 to both sides. That would then give us x squared minus 4x plus 4 equals 0. Now we have our polynomial in standard form, and it equals 0, so we can solve. So again, our first question is, does this have a greatest common factor? And the answer is no, so we can move on. So let's set up our diamond. AC here, 1 times 4 is 4. B is negative 4. So we need to find our two numbers that multiply to positive 4 and add to negative 4. That's going to be negative 2 and negative 2. So now we can write this out as x squared minus 2x. Again, for the second term, I'm going to write this as plus negative 2x plus 4. Now we group them, and we can factor. So this becomes x minus 2, and we can factor out a negative 2 here. So we get x minus 2 times x minus 2 equals 0. So now we can solve for 0. So now we can solve for x. In this case, right, both of them are x minus 2 equals 0. So we solve, and we get x equals 2. All right, so our last one here, we've got 2a squared plus 8ab minus 3a minus 12b. So you'll notice we have 4 terms in this one. Now generally when we see 4 terms, we will factor by grouping. So let's again first just check if we have a common factor that we could factor out here. We've got 2, 8, negative 3, and negative 12 as our coefficients. There's no single common factor for all of those, so we'll go ahead and move straight to factoring by grouping. Okay, now again, I'm going to rewrite my negative 3a, or my minus 3a, as a plus negative 3a. And then we will factor out our common factors here. So in the first one, I can factor out a 2a, and that would leave me with a plus 4b. And in the second one, I can factor out a negative 3, which leaves me with a plus 4b. So my final factored form would be 2a minus 3 times a plus 4b.